Well, good afternoon. It's been a very long time since I posted to the channel. There's big changes in my life this year. After 25 years, I left Microsoft in January, took a long vacation, and just recently decided that I would get back in and do a little bit of consulting work. So I've been getting that up and running. Some interesting stuff around NXP Freescale and firmware dev and so on. Anyway, I saw this come up. Sean Blakely on the EEV blog had a trove of HP gear, and this was one of the items that he had for sale. This is a 5343A microwave frequency counter. And in some of my past videos, you might have seen me using the 5342A, which was the little brother of this thing effectively. This one goes up to 26.5 gig, and it uses the same technique to count up to that frequency, which is a harmonic heterodyne technique. What that means is that, like most frequency counters, the heterodyne part, what it'll do is it'll take a VCO inside, and it will scan that VCO, increment it, up the frequency or down, depending on the architecture, and wait until an intermediate frequency from the mix of those two appears in the counter region, or appears to the counter and then can be counted. Now, knowing the frequency that your VCO is at, that can tell you what the frequency is of the actual incoming signal. And that's a very common method of doing it, especially in lower frequency counters. Going up to 26.5 gigahertz, that becomes difficult, because it's very difficult to make an oscillator that's accurate and can be swept all that way up and down. And so HP, when they were designing this, added a second technique, and that's where the harmonic part comes in. Remember I said it was a harmonic heterodyne counter. What that harmonic part means is that it applies the same process to the VCO. So it starts it and sweeps it, and it looks for something to appear inside the low frequency counterpart of the unit. And when it finds that, it can then take the next step, which is to work out, is that, which harmonic is that signal from the input, or from the VCO that it's actually getting. And so what it does is, effectively, you can take one reading at the VCO, and then you can move the VCO by a known small amount and take another reading. And then based on whether the intermediate frequency moves positive, negative, and so on, you can then work out what the harmonic is. And then it becomes a simple math problem of saying, well, if I'm reading X harmonic, I can multiply the harmonic by the number that I'm reading, and therefore I can get my my VCO, my final counted frequency. And so that makes the design and build of a 5343A type counter much, much easier. And there's a great discussion of how harmonic heterodyne counting works inside the manuals, both for the 5343A and the 5342A in the theory of operation. It's one of the things that I miss about manuals these days. The old HP manuals had that great theory of operation section, which enabled you to understand the design and architecture of the instrument. Anyway, this frequency counter I bought has the ability to count single-digit hertz up to 26.5 gigahertz. It has manual control of the sample rate. You can control that using this. There's usually a knob that sits on here, but that's been broken off, so I'll have to go look for a replacement knob. It has that split input between 10 megahertz and 500 meg coming in on this port here, and 500 and 26.5 coming on this port here, and this is an APC35 connector. So you can tell it to go and do a resolution check at a certain, you present your data at a certain resolution. Now that's typically useful if you have a signal that wanders around at a lower value, and you want to get rid of the noise so that you can just focus on the primary part of the signal. And then it has the ability as well to integrate with a sweep generator. A sweep generator such as the 8350B, and I just bought one of those by accident, actually, and we'll do a video on that probably around the summertime here in the US, because I have to get some plugins for it. Anyway, what you can do is you can connect some cables that plug into the back of the unit. We can see those here, that will control the sweep and let the frequency counter stop the sweep, read the frequency, continue the sweep on, read again. And this way you can get an accurate reading rather than without needing to manually set a CW setting on your sweep generator. And this is great for automated tools, for things like network analysis. These were often bundled in with that 8350, and they enabled you to look at that frequency. So let's turn this on, and we can see that the unit is turned on, and it's not reading anything at the moment. But you can see this little LED flash here, and this is the visual thing telling you the sample rate and how fast it is when it's coming and sampling. And as I turn that down, you can see that it takes longer and longer for the little red light to flash. Actually, I might have turned that too far. If you turn it right down, it'll actually just hold whatever the thing is that you've read. And now I can turn that back up, and you'll see that it's a much faster gate rate. So let's grab a signal, and I'm just going to connect in my 8340B. And I have my 8340B set to 26 gig. And you can see that out of the box, it's doing pretty well. I have a GPSDO, old HP satellite unit that provides 10 meg. And I don't have this connected into the 10 meg, but still, it probably hasn't been tuned in quite some time. And so we're still getting pretty good stuff there. Let me set, say, a different frequency. Say 11 gigahertz, and we'll see that it drops down and shows that. So I'm pretty happy the counter is working well. I wanted to get this counter because it's the recommended test gear for some of the other pieces of kit that I have, and I love having the actual piece of gear that HP put in the manual, so that when I can go test something, I can use exactly what they've got in there, and I see exactly what they were seeing when they were writing that. I have a 5351 that's also a 26.5 gig counter that I would use normally. Anyway, that's the counter. You can see that, you know, if we start, if I come in, whoa, that's interesting. Oh, shift, sorry. You know, you can set and say, okay, I want to only read to the nearest megahertz, and so on this resolution panel, we have a shift button and the thing to tell you what the shift is. We have the ability to tell it to do automatic frequency maintaining. So let's go back and just say 1 hertz. And if I type in, you know, say 5 gigahertz, it'll automatically go and find that frequency. And it does that by looking for the highest or the most power frequency that it gets inside the range that it goes looking. If you have signals that are close together, you can tell it to be manual and say, you know, okay, sorry about that. Drink of choice today is just a nice Jack Daniels on ice. Anyway, let's go back to check manual frequency. If you wanted to get if you had a signal that had peaks that were very close together, and you want to manually set the frequency, you know, you would come in and say hit manual. Oh, no, you would come in and say, let me reset that. We're going to go to auto, and then you would say set manual to 1, 2, 3. Say I want 11 gigahertz, and that it's going to jump up to that period, and then if I set 11 gigahertz on my frequency counter, you'll see that it'll now start reading that. So if I went back in and said set manual, say 3.5 gigahertz, we don't get proper counting until I set 3.5 gigahertz on my 8340, and now we're counting back correctly again. And you've got to know the center frequency that you want to count within about 40 megahertz or so. So this has some other features like offsets. You know, if you are measuring something that is going to come out of a mixer or so on, you can give it an offset and let it know what the incoming offset's going to be, and then it'll automatically add that to the value displayed, so you don't have to manually calculate it. It has that sweep function I talked about. One of the things that's different between this and the one that I had previously is that that 5342A had a ability to measure the incoming signal power as well. This unit doesn't have that, and it wasn't added as an option. But if you can get one of the old 5342As, they're actually a pretty cool little unit if you don't already have something that can measure power, because you'll be able to do both together. And in fact, the way they measure power is quite interesting. It's worth having a look in the manual. They effectively turn the power input into a signal that they count. So they use the counter itself to go and do that. If you're looking on eBay, one of the biggest, or you're looking at secondhand, well, so obviously secondhand, but if you're looking at auction units or so on, one of the biggest things that can happen with these is that the front ends are very sensitive, and so they can get blown quite easily. And you'll see a number of these things where the input will be blown. They will still count, but the way to sort of tell that is if you're asking somebody to give you a screenshot or so on, or to show that the unit's working, ask them what minimum power level they need to put into the unit to be able to still get an accurate count, or still get it to count. And if that input power is not within the spec of the unit, I'd have to look at the manual to find a spec. That's telling you that they're going to have to put more power in to drive through that damaged front end. Anyway, that's the unit in operation. Let's take a quick look inside. Okay, so here we are inside the unit, and some of the stuff that we can see right off the bat is this is the 10.8.11 crystal oscillator. This is the update or the option, usually a 001 for a high stability time base for the unit. So these are actually very good little oscillators. This unit also has option 011, which is the Gpib controller, and we can see that in there. Interestingly, when I just took the top off, I noticed that there are some screws missing. So I would assume they would have been there originally. So it looks like somebody's maybe taken a shot at fixing the power supply. This section is a power supply here, and this is all of the smarts of the unit over here. So let's just undo these screws a little bit, take a quick look in the power supply area, see what we see. Okay, so these actually, these units run at quite high voltage in here. So you really should be careful when you're working on these, because of the 300 odd volts that you'll get inside these power supply areas. From where I sort of sit, I don't see any changes. I'm not going to pull out the cards. But again, in classic sort of Hewlett-Packard format, they've got a bunch of these test point at the top of the card, so it makes it easy to test these in place to find out. I'd imagine that'd be to set one of the rails or the reference rail. You know, and you can put this stuff on extenders. There is an extender kit for this. The extender kit comes with a, you know, mostly they're like, I think they're like 22 and 11 slot connectors and many other pieces of Hewlett-Packard gear. Hewlett-Packard used cinch connectors, I think it is, and they were common across all of their gear. So often you can get a HP extender board for another piece of gear that will work just fine for what you've got here. The one thing is this had quite a complex extender for the digital board, the microprocessor board, and that's going to be in this section here. So let's take a quick look and see what we get in there. I'm going to put the lid to that back on so that I don't do something silly. So here we have the various boards. You can see the classic shielded can section. This, where are we? Here's going to be your, what looks to be your microprocessor. It's probably the HPIB board. And so stuff. Let's take a little look at that. Let's see if it comes out easily. I don't want to pull these little rings off. There we go. So yeah, so this will be the processor board. You can see the probably a little Motorola, maybe a 6809 or something like that. You know, 4 megahertz clock running next to it. There's a lot of that wasn't populated on here. I wonder if this is a mixed board, you know, that they would use in the 5342A. Anyway, you can see the connectors in here. If you look down in here, this is going to be the where you would put that. You'd put the expansion, the extender card in here, and then drop this guy in on top of it, and you'd be able to debug the processor board. This is the only one that has that sort of complex extender requirement. Well, that, and I think the HPIB board has as well. Everything else should just be a single extender card that you should be able to put in. But you see it's classic discrete components. Let's take a look at something a little more in see, that's the problem that happens there when these boards get stuck in. So clearly somebody has been in here at some point. Trying to get them out, you can break those little rings off. Anyway, I don't know if there's a lot more of interest in here. You know, there's it's tilted on side. So, this is where you get that front end area that comes in here. This is going to be the bit that will blow up if you have them overpowered. Anyway, the basic run of this is you have some oscillators up the front here. You have your control stuff here. You're going to have the IF detection in here, and you'll do the mixing, then do the detecting. And that's separated from the power supply and shielded in as well. I suspect that they put these things in here because it enables you to work on the device and then shield it up while you're repairing it or trying to debug what was going on. So this little front end, this little sampler up here is the thing that will actually often blow. And if I have a look in there, it looks like maybe somebody's actually already taken a go at the screw there. So I suspect maybe this is blown and it's been serviced at some point. Anyway, the front panel boards there, you have that classic 7-segment red display. Hopefully you guys will have found this this interesting, and just a quick look at an old frequency counter. And hopefully I'll get back into the process of dropping in some more content on the channel. Anyway, look forward to speaking to you later. Bye.